Hi, I'm Oliver, the creator of the UNICORN Binance suite. In this video, I will install the UNICORN Binance DepthCache Cluster, in short UBDCC, on Kubernetes and turn a small Kubernetes cluster into a Binance order book service. I'm following these instructions of this article. So here you can find all the commands and installation sources I use in this video. After the installation, we will create a first DepthCache manually, query it over REST, open the dashboard, and then create all currently active Binance Spot and Futures DepthCaches with 2 replicas. This video is about installation and functional validation. It's not a live Grafana Cloud K6 stress test rerun. I already documented the paid stress test separately in the article linked in the description. The idea behind UBDCC is simple. Instead of every bot, dashboard, or strategy service maintaining its own local Binance order book, the order book infrastructure runs once as a shared service. UBDCC maintains the Binance DepthCaches, keeps them synchronized, can run replicas, and exposes the data over REST. So your clients do not need to rebuild and maintain the same market data logic again and again. They can simply ask UBDCC for bids and asks. If you don't want to start with Kubernetes, I also made a local quick start video. That one starts with pip install, runs UBDCC locally, opens the dashboard, and creates the first local DepthCache. This video continues from that idea and moves the setup into Kubernetes. So today I use Vultr Kubernetes with 6 worker nodes. UBDCC will be installed with Helm. I will not use any Binance API credentials. This test only uses public Binance market data. The exact number of active markets is not known before the run because Binance can add, remove, or pause markets over time. So the script creates all currently active spot and futures markets, and the final count is visible afterwards in the dashboard. One important point before we start, this is not a Binance stress test. Binance is only the public market data source. The REST calls in this video go to my own UBDCC cluster. So the thing I'm validating is my own Kubernetes-based order book infrastructure, not Binance itself. Okay, here is the Vultr Kubernetes cluster. For this run, we use 6 regular cloud compute worker nodes. Each node has 2 virtual CPUs and about 2 gigabytes of RAM. Choose your preferred location. Okay. This is intentionally not a high-end cluster. It is a low-cost baseline setup, which makes the result more interesting. If this can run a large number of replicated DepthCaches, then that is already useful for many test infrastructure scenarios. In the meantime, if you don't have kubectl installed on your system, please install kubectl by following the official instructions for your operating system. You can find the link in the description and in the article I mentioned in the beginning of this video. After the cluster is created, I download the kube-config file from Vultr and place it into my user's home directory. This works exactly the same way on Linux, Windows, and Mac OS. Just go to your home directory, create the folder .cube, Okay, the cluster is ready. It's running. So now I can continue downloading the configuration file. I already created the folder in my home directory. The config file is downloaded into my downloads folder, and now I copy it or move it to kube-config, not config.txt or something else, just config, also on Windows. Perfect. Okay. Then I check if kubectl can talk to the cluster. It can. Perfect. So if the nodes show up as ready, the connection to the Kubernetes cluster works. I want to show you -O wide. Here you get more infos. IP address, operating system, Okay, so yeah, since we are connected, I can keep it open. Okay, important next is you have Helm. Helm is the package manager for Kubernetes. Please also install Helm according to the official instructions for your operating system. I will include the link in the description as well. UBDCC provides a Helm chart, so the installation is basically a few commands instead of manually creating Kubernetes resources one by one. The next step is now I install the Kubernetes metric server. This gives me a quick CPU and memory information for nodes and pods. Later, I can use commands like kubectl top nodes. If kubectl top nodes says that the metrics API is not available yet, just wait a few minutes and try again. This is normal right after installation. Oh, ready. Perfect. Next, we add the UBDCC Helm repository. I already have it. Next step is you update the repository with Helm repo update. So Helm has the latest chart information. Okay, everything is prepared now. And now I install UBDCC into its own namespace. The important setting here is dcn.coresPerNode equals 2. You can change this to the number of CPU cores you have. This is important. DCN means DepthCache node, and the DCNs are the components that hold and maintain the actual Binance DepthCaches. With this setting, UBDCC starts DCN capacity based on the available node cores. Okay. 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 Now I check the pods. Important is the namespace UBDCC -OY. I want to see the management pod. It's this. The REST API pods, but they are all not ready yet. And the DCN pods. The -OY output is used because it also shows on which Kubernetes nodes each pod is running. For this kind of test, pod distribution matters. I do not want everything packed onto one node. Good. Next, I need the public REST API address. Kubernetes created a load balancer service for the UBDCC REST API. I can find it with kubectl get svc and named as UBDCC. It's not ready yet, it's pending. The external IP address of the REST API service is the address I use for curl, the dashboard, and the helper scripts. A second command to get the IP address is this. Here the IP address is also missing. It will show up here between these two fields as soon as it's ready. Oh, it's ready. So we should also see it here now. It's the VIP address, load balancer ingress. Perfect. So our IP address is this. Okay. Yeah. In these examples, I replace your UBDCC IP with this IP address. Next step is I start the UBDCC dashboard. It automatically opens in my browser. The dashboard is actually not required for automation, but it is very useful for visibility. Here I can see the cluster state. Wait, I can show it. Since we use port 80, we don't have to mention it explicit. Connected, and here you see the cluster. We have 18 pods, 6 REST API pods, and 12 DCNs. At the moment, here is no DepthCache. Here you see also the DCNs, and later you can see which DepthCaches they are hosting. Also, the replicas are you can see here, and the synchronization status. For this video, the dashboard makes it much easier to see what is happening inside the cluster. Okay. Next step. We use curl. I prepare the command. Important, replace this field with the correct IP. Okay, before creating all markets automatically, I create one DepthCache manually. I use ETH BTC on Binance Spot and request 2 replicas. Yeah, this is the amount of replicas, the desired quantity. It means that UBDCC should maintain 2 synchronized instances of the DepthCache. You can choose also 10 if you like. And that's the basic idea behind the redundancy mechanism. Oh, okay. Event DepthCache, create DepthCache result. Okay. We look into the dashboard now. Reconnect. Here is the DepthCache we created. If you like, you can also stop DepthCaches here. You can also add DepthCaches here. Just a small test. Also with 2 replicas each. Okay, so we are online. The replicas are starting with a delay. This is part of the algorithm. Okay, good. Then the next step is I request the asks. And I also request the bits. The limit count parameter limits the response to its first 100 price levels. We can switch this over to 500, or we can leave it to get the full order book. This simple test proves that UBDCC is running, the DepthCaches exist, and the REST API returns order book data. We have an optional, we have the option for simple monitoring. We use kubectl again. Show all of the commands, and then we combine them with a watch command. kubectl top nodes, kubectl top bots in the namespace UBDCC. I like this watch command. With n1, it refreshes every second. And then I place the command, for example, kubectl top nodes drugs, and we can combine them, and kubectl top bots minus n UBDCC, and we combine with the last two, kubectl get bots minus n UBDCC. Okay, now every second this refresh, and we can monitor. Yeah, the top nodes command shows the CPU and memory. The top bots shows pod resource usage, and get bots minus O shows where the bots are running. If you want a live view, you can wrap up these commands with watch as we did. So next step is the helper scripts. I use helper scripts to create and test a larger set of DepthCaches. The scripts are available as gists. Yeah, you find all of them here in my gist repository, also linked in the description below and in the original article. I already have them on my system. But I have to replace the IP address first. So let's start with this step. Okay. The first script creates all currently active Binance Spot DepthCaches. The second script creates all currently active Binance Future DepthCaches. The other scripts are for testing, querying asks, querying bits, and stopping all DepthCaches again. The exact number of markets is not hard-coded. It depends on what Binance reports as active at the time of the run. Okay. So first I create the spot DepthCaches. This is the important command here. The script talks to the UBDCC REST API and creates, yeah, here it gets, no, here it's asking the Binance backend for all active markets. Then we create for every active market 2 replicas. Okay. So we created, or we are creating 1,371 DepthCaches for Binance.com. While this runs, I watch the dashboard and the Kubernetes resource usage. The important thing is not that the request were sent, but that the DepthCaches actually become synchronized. Next, I create the futures DepthCaches. It's actually the same script, just connecting to futures. So we are adding 642 more DepthCaches. So now we have 2014 DepthCaches with 2 replicas each. So finally, there are 4,028 DepthCaches now in the cluster. So after both scripts are done, I wait until all DepthCaches and the replicas are synchronized. Oh, it's waiting. It's time to wait. Now we wait for the synchronization. This is important. UBDCC has to create the DepthCaches, load initial snapshots, connect to the live depth streams, synchronize the books, and create the replicas. I do not want to test a half initialized cluster, so I wait until the dashboard shows that the created DepthCaches and replicas are ready. In my documented stress test run, the final result was 2013 markets, 2 replicas each, so 4,028 replicated DepthCaches in total, and that took about 25 minutes to synchronize. But the exact number can change over time because Binance market change. For testing, I also have a script. It doesn't query all the information and shows it. It just collects them and analyzes the status of all DepthCaches. We have to enter the IP address first. Test all DepthCaches. This script queries all DepthCaches from UBDCC that are available and is testing them. This is not a benchmark, it's just functional validation. The script checks whether the created DepthCaches can be reached and queried through UBDCC. That is a different question than load testing. Here I just want to know, do the created DepthCaches exist? Are they synchronized? Can I query them through the REST API? Okay, I think now we wait, and I will be back in a couple of minutes. Here you see the successful tested DepthCaches. 5001 means actually it's returning valid data, but it asked non-working DepthCache before, so it's not fully synchronized, but available, just without failover at the moment. Yeah, maybe this is the demonstration effect. Yeah, till now it doesn't work. Maybe the market doesn't work, but we continue. All other markets are working. We have replicas, just a small few here. We go through all depth caches and they are working. Just the one Floki DR is not. It's not the full list. Where is it gone? Okay, continue. Okay, next step, we query asks. For this, I have the script UBDCC asks. I enter the new IP address. An interesting switch is this. I will show the difference. Debug true or false. And now we query all asks from all markets. And what's very interesting is debug. We switch it to true now. Start again. This gives you more information, this debug block. It shows the cluster execution time. So this request needed 0.0118 seconds in the cluster. So when the request hits the cluster till it serves the result, it needed this time. The whole request time is this from client, when the client sends the request and gets the result. And this is the transmission time. Yeah. This is the URL that was used. And here you see the bots that were used. This was the REST API bot. And this was the DCN that served the data. This for sure works also with bits, the same way actually. And we also can do a few curl checks. The nice thing now is you can use any language. For example, now I query with curl. And I use what I have prepared. So yeah, these are actually just simple REST calls, no special client libraries required. Any language or tool that can make HTTP requests can consume the service, like Nathan and even Microsoft Excel, Google Sheets, LibreOffice Calculator. The big Grafana Cloud key6 stress test is documented separately. I'm not rerunning it in this video because the test was paid and cost me already about 100 euros. I canceled Grafana Cloud afterwards. The article contains the full result, smoke test, distributed plateau test, hot market ramp, fast limit finder, and the difference between distributed market load and a single hot market workload. If you want the real K6 numbers, read the article linked in the description. I can show it here. Here find all the information. And the test results. Here you can start. Okay. One important cleanup reminder, if this is only a test, delete the resources afterwards. That means the Kubernetes cluster and especially the load balancer. In Vultr, you see this here. Just delete the cluster by clicking on delete. And also go to network and remove the load balancer. Okay, this is the full Kubernetes setup. We created a managed Kubernetes cluster, initialized UBDCC with Helm, created a first DepthCache manually, queried it over REST, opened the dashboard, created all currently active Binance Spot and Futures DepthCaches with replicas, and validated the setup with helper script and curl. The main idea is simple. Build the market data infrastructure once, keep it synchronized, add replicas, serve it over REST, use it from any language. That is what UBDCC is called for. If you want to try UBDCC locally first, watch the local quick start video. If you want the Grafana Cloud K6 stress test results, read the article. The GitHub repository and helper scripts are linked in the description. If something is unclear, missing, or does not work in your setup, please leave a comment. I'm especially interested in real-world results from different Kubernetes providers, different node sizes, and different market data workloads. Thanks for watching and happy coding.